Welcome back to the people track. We've got 2 down and a bunch more learning to go. Next up, we have Chris Stephenson, the CTO of Humanitech, talking about developer experience. We love developer experience. And while you're listening, don't forget to set up those networking and prepare for a wonderful break or lunch and draw. And I'll catch you on the other side. Take it away, Chris. Thank you.
So thank you very much, Jennifer. And so welcome to this talk. I'm going to be talking about why is developer self-service still hard in the cloud, and more importantly, what to do about it. So as a very lovely introduction from Jennifer, my name is Chris. I'm CTO of Humanitech. Humanitech is a company that builds internal developer platforms that will become relevant later. I've also been involved in software development for quite a while, at a whole range of things, from startups through to big tech through to financial services. And one of the recurring themes I've seen in all of this is developer platforms and the problem of developer self-service. So going into what we're going to be covering, we're going to split this into 4 parts. We're going to start out with the promise of the cloud. So why do people actually want to go to the cloud? We'll also cover the reality of the cloud, and then specifically the problems to do with developer self-service that exist in the cloud. And then finally, the most important and probably awkwardly named, the what to do about it part of this talk. So let's get kicked off with the promise. So the promise of the cloud. What as a developer or what as an organization do we get from the cloud? Well, the cloud has a load of things which people are very excited about. One of the things is pay as you go. If you don't have to buy all your infrastructure up front and stick it in the data center, but you can just pay for what you need, that is fantastic. On demand, if I don't need something, I can turn it down and not have to pay for it. I can spin it up if I need it. If I need to expand, I can also use more resources. It's elastic. This is fantastic. And maybe the most exciting thing, as far as companies are concerned, is that it's generally managed by someone else. You don't have to have technicians on the ground to chase down a rack that is misbehaving. You don't have to have someone plugging network cables into things. This is managed by someone else, which is fantastic from an organizational perspective. If we switch over to the developer side, the promise of the cloud for developers is that everything is at your fingertips. You have these cloud consoles where you can create resources that do what you want. If you need a database, you can click a few buttons and you can have a Postgres database running in the cloud that is automatically scaled and has high availability configured. You can spin up VMs, you can set up message queues. All of those things are just a click away within these very fancy cloud consoles that exist. And the best thing maybe for a developer is that because you're using the same kind of infrastructure that everyone else is using, you can use Stack Overflow to answer standard questions. If you're having a weird error, like for example, maybe you have Kubernetes ingress reporting fake certificates, a quick search in Stack Overflow and you can find other people who've had the same issues. This might not be possible if you're running on your own infrastructure in your own data center, because the configuration, the many ways that all of the bits of technology that have been put together will probably mean that your problem might be relatively unique. So this concept of the cloud makes a lot of sense for people who are developing in the cloud. You get a lot of bang for your buck. And then the next kind of big thing is if you're in the cloud and you don't have physical infrastructure, then your developers and your operations can be one team. Especially if your developers are provisioning their own infrastructure, maybe you kind of don't need an operations team. Maybe the developers can do it. And then we've all been told that the best thing to do is to do DevOps. You know, developers and operations working together, or maybe even developers and operations being the same person. If developers are provisioning their own infrastructure, then it's kind of DevOps, right? So we're even adopting a more friendly and a more modern approach to doing development. So in short, the promises of the cloud are pretty huge. There are a lot of advantages, and a lot of people are very excited about it and have been for probably about a decade now. But of course, the reality is somewhat different. There's a reason why we're having all of these talks. There's a reason why there's a whole conference about people trying to go cloud native. And the problem is, the reality is that the promise is not usually borne out in reality. So the first thing to notice is that rather than being a magical place where everything is fixed for you, basically the cloud is just somebody else's data center. I mean, if you're using GCP, then that is a Google data center that is running a load of stuff. And okay, you've got fancy APIs to spin up instances of things you want, but fundamentally it's someone else's data center. It has all of the same problems. You still need to deal with networking. You still have security policies. You still have to work out how to get people to access what they need. All of these problems still exist in the cloud. It's just that they're now behind fancy consoles and fancy APIs. So it turns out that this makes it not as straightforward for developers to just jump in and be the heroes of the moment as maybe they were hoping. Then the other thing is, if your developers are in charge of everything and they have full control over everything, then you also have the risk of screwing things up in a very powerful way. So with great power comes responsibility and also the possibility of screwing things up. Examples of problems that people have had with cloud setups, the most common one would be cost overruns. It's very easy to set things up that become very, very expensive very quickly. You just have to configure some batch jobs incorrectly for them to elastically expand to use huge numbers of resources, and suddenly you're sitting on thousands of euros or dollars or pounds of cloud bills very, very quickly. Security is another problem. It's very easy to mess up security, especially if people are not super familiar with the details of setting up cloud-based security. And then finally, audits. Like if you're a bank, you still need to know who can change what happens where. If you give developers access to everything, audit becomes really hard. How do you check that everyone is doing the right thing in the right place, that everyone's had the right training and so on to be able to do things? And finally, the most important one, I think, is actually to do with reproducibility. You know, you're running stuff, you have these fancy cloud consoles. How do you make sure the thing you've done in the development environment can be repeated in the staging environment? And then the final kind of problem or the final bit of reality that turns out is when you switch into a kind of DevOps structure, especially in the cloud, is you thought that you are going to make everyone work in a kind of DevOps way. In practice, what we see is that most people end up introducing a DevOps team. So what you actually do is you increase the number of teams that you're involved in. You have your operations team, you have your developers, and then you have this DevOps team that kind of sits in the middle, sometimes helping out, sometimes getting in the way, sometimes making things faster, sometimes slowing things down. So the promise of the cloud, again, in reality, is much harder to realize those promises than you might think. So we've had the promise, we've had the reality. Let's dive into the exact problems that exist. So I think there are three problems from a developer self-service perspective in the cloud. There are lots of other problems which we've kind of talked about, but let's focus on developer self-service specifically. So the first big problem with developer self-service in the cloud is that most developers are not experts in cloud services. They don't actually know how things work, or they've read a few articles, but they don't know the details. This means it's very tricky for people to do the right thing. Often there's a lot of trial and error, there's a lot of iteration to get to what you want, and then this causes a load of additional problems down the line. Fundamentally, cloud technology is complicated, and it's probably unreasonable to expect someone who is a developer who's focused their time in, say, building enterprise Java applications to also be an expert in the entire cloud stack. Then the other problem is cognitive load. It's kind of related to the first one. There's this concept of cognitive load as in the amount of stuff that people have to deal with to get something done or to do their job. So, for example, if I am a developer who needs to set up a database or something, then maybe I end up doing a lot of work around setting up the database, which is not helping me as a developer get my code running in a cluster or available to customers. There's a load of additional work. This has actually been explored in quite some depth in a book called Team Topologies by Manuel Pais and Matthew Skelton. I would highly recommend that you have a look at that. Cognitive load is a great source of problems for developers and something that really slows people down. And then finally, the third problem is something we mentioned earlier, which is reproducibility. So we want to do the same thing again. Maybe we start off with an ops versus dev approach. So devs tell ops, hey, we need this, and then ops go and do that. But we say, okay, we're now in the cloud. Everyone does DevOps. Fantastic. We're in a very good position. So now devs are provisioning their own cloud infrastructure. They get their dev environment all set up. It's all working nicely and shiny. And then you ask them to move those changes across to a staging environment so that you can reproduce what's going on. Suddenly you have to manage hundreds of changes made by tens of different people in different environments and work out, are they the same? Are they different? How are we sure that what we set up first time round is the same as what we set up second time round is the same we set up third time round? So this is a very, very real problem and something which I think a lot of teams are struggling with. So we've covered the promise, we've covered the reality, and we've covered the key problems. So let's move into a more positive note. What do you do about it? What are you going to do? How are you going to allow developers to be more self-service or self-serve themselves in the cloud? So the first thing to actually figure out is what you want. And I think basically what people want is all of the good stuff about the cloud with none of the downsides. So in our case, the downsides are that you don't want your devs to be needs to be experts in cloud infrastructure. That's kind of the first thing. The second thing is that you don't want people to be distracted. You don't want them to have to think about stuff that is not related to their main day job in order to serve things in the cloud. And finally, you want to make sure that changes that are made to cloud environments are reproducible and reusable. So I think that's kind of a reasonable frame. Let's kind of look at it and find out what the kind of core problem is. I think personally, the core problem is one of complexity management. So in general, developers know what they want. They just don't necessarily know how to get it. So one example is, imagine you're provisioning a new Redis cache, and a developer says, yeah, I just need a new Redis cache because my service needs to cache some data. Fantastic, right? So how do you do that? Well, maybe if you're using AWS, you go to Elasticache for Redis. In GCP, you might use Memstore, or you might run it, say, in a Kubernetes cluster you're already using. So that's already a load of questions, a load of decisions that a developer has to make. Then you've got the next level. So how do you configure it from a security perspective? Does it run in its own VPC? Or you have this concept of virtual private clouds in all of these cloud providers. Should it have its own? Should it be in it? Should it be peer together? Do I need to set up firewall rules? Do I need to set up authentication on my Redis cluster? What is our security policy on this? So even as a developer who just wants to set up a Redis instance, there's a lot of stuff that they have to think about which is outside of what they need. So how do you actually make that work? How do you deal with that complexity? Ideally, the developer just wants to get their goal done, and then they want to be able to move to the next step. How do we take this complexity of the cloud and then shrink it down in a way that our developers can self-serve what they need without having to be experts, without having to have all of these things in the back of their mind when they're trying to set something up? So there's something which I think personally is not quite up there with the laws of thermodynamics, but is something that once you think about it is at least intuitively true. And that is, you can't remove complexity from a system. But you can move it around. So you can put it somewhere else. So for example, cars today are easier to drive than cars 100 years ago. cars 100 years ago, you needed to have a detailed understanding of how your engine worked. You had to do something called double declutching to change gears. Today, if you drive an automatic, you don't even need to think about a clutch. In 5 years from now, you'll just be able to tell your car where they want to go, and you won't even have to think about steering. So from a driver perspective, it has become increasingly less complicated to drive a car. But where has that complexity gone? The complexity has gone into the car itself. So we now have like self-driving systems in cars. We have synchronizers built into gearboxes to make the clutches work. We have all sorts of these things which have been added to the car itself to make the life easier for the driver. So that is, as a kind of concept, is where we need to go when we want to improve developer self-service. How can we take the complexity and move it away from the developer and put it somewhere else where it doesn't bother the developer? Now, there has been an attempt at this before, and there's been kind of a relatively successful way of doing this, which is known as a platform as a service. So the idea of a platform as a service is a load of smart engineers have built a tech stack which is quite flexible, and then sold it to other developers who don't want to have to figure out how to build out their tech stack. This works pretty well, actually, if you have a simple case that lines up to what the original engineers were talking about. So a good example you may have heard of is something called Heroku, which actually works very well for relatively straightforward applications that are not scaled too big. The problem comes with these kind of platform as a services is that as soon as you leave the sweet spot of what the original engineers had in mind, you are now in a world where you have to take things into account. You have to maybe bend how the platform works, or maybe you just flat out can't use the things you want. Maybe it's too expensive to scale. Maybe it is not compatible with a bit of technology you want to use, and so on. So in short, you have a platform as a service. You give up control in exchange for convenience. We are pushing the complexity away from the developers. So developers can say, here, I need a new service. Great, platform as a service gives me that new service. Fantastic. But you don't have control. You don't have much choice over how that service is put together. You don't have much choice on what it's running. And so you're kind of stuck with the initial choices that have been made. But you, on the plus side, it's less complicated for developers, so they can move faster and they can do a certain amount of self-service. So that's kind of one approach, but it isn't the dominant approach today. I just want to take a kind of a brief secondary look and revisit this car metaphor. So when we were talking about cars before, we were talking about complexity of the building. Another thing that's interesting about cars is that we don't build cars just with mechanical engineers. We have a whole suite of people. We have aerodynamics people. We have thermodynamics people to look at the engine. We have logistics people to work out how to get all the bits on the production line. We have operations people who know how to build production lines. We have quality assurance people. We have all of these people. And actually, building software is similar. Not everyone needs to be an expert in everything. And if you're a developer, maybe you don't really want to know the details of how cloud level networking works. Maybe you don't really want to understand what the trade-offs are for putting together a Redis database. So what we have here is, if we think about software development as a group of people working together as a team, rather than everyone trying to be kind of a lone ranger and doing everything themselves, if we put people together in a team, we have another way that we can split complexity. We can split it amongst the team. Maybe this is a little bit counterintuitive from a DevOps perspective, where we're saying everyone should be able to do everything. Maybe it isn't a case of everyone being able to do everything. Maybe it's a case of everyone knowing what they do well and making sure that they collaborate together when they're actually building something. A bit like a team of people building a car. We bring people's experience together. We bring the operations people together. We bring developers together, and together they can work out a way of provisioning something so that developers can get moving in one way and self-serve what they need. Now, there is a concept which has been gaining ground recently, which is trying to address this problem. How can we bring everyone together? How can we give like a PaaS-like experience, but not have to worry about what is going on under the cover? We don't have to be tied to some compromises have been made by an engineering team over there that we don't know anything about. And that is an internal developer platform. As our friend Kelsey Hightower said, most people want a PaaS. The thing is that they want to build it themselves. And so the question here is, can we come up with something which actually allows us to do that? Well, the answer is yes. It's a concept called internal developer platform. It aims to have a great developer experience powered through self-service. And at the same time, it should allow operations people, people who know infrastructure, people who know about system setups, to define and manage the kind of baselines and what is required in order for them to get a reliable and reproducible system up and running. So the key thing about internal developer platform is that there are two stories. There's one for devs and one for the operations team. Let's focus on the self-service elements specifically. For developers, you get to provision your own infrastructure, you get to create dynamic environments, you get to run your own deployments, and you get to manage your application configuration. So as a developer, in theory, I can do everything I want by saying, hey, I need a thing, give me a thing. I need a new environment, give me a new environment. Oh, and I want you to deploy this. Great, it's deployed. And yeah, I have all of these configurations which need to be lined up to different environments. Can you deal with that for me? Fantastic. On the other side, of the operations side, we try and make sure that the operations team are not getting in the way. So rather than developers saying, hey, I need a thing, operations team, can you go and set that thing up for me? They can set up the internal developer platform to create the thing to their specifications. They can control the baseline configuration. So you can say, hey, if you set up a Redis, it's going to be running on Memstore. It's going to be connected using this security policy. You're going to have it be authenticated. We're not going to have any anonymous access to our Redis instance. And it can set up guardrails. You can say, hey, developers, you can go this far, but if you want to go any further, then maybe we should take a second look at things. And most importantly, you should be able to extend it. It shouldn't be something that locks you in. You should be able to take it and it should grow and develop with your business. So this is actually something that has been done for many years by so-called big tech. I mean, the classic example would be something like Google. So Google has all of this kind of infrastructure, same with Facebook, same with Netflix. Maybe we're not all these kind of FANG companies, but there are smaller companies who are doing this as well. We have an example, Airbnb recently had some great talks on how they've built their internal developer platform. GitHub has increased the rate of their development by introducing an internal developer platform to make their developers become more self-service. And Zalando is a nice European example of a company that has used a internal developer platform to great effect. So in summary, what is the solution to cloud-based, to developer self-service in the cloud? Well, introducing some kind of internal platform with an internal platform team to run it, which will actually provide you, your developers, with a simple and easy-to-use interface into the world of cloud resources, backed by an operations team or an operations function that can provide baselines and all of the kind of basic functionality that they need in the background. So that is kind of a very quick guide, introduction to internal developer platforms for you. I have a few links which maybe you can have a look at, or things that might be interesting for you to consume later if you're interested in the topic. Internaldeveloperplatform.org is kind of a community site. The platform engineering Slack community has been growing with platform engineers from companies around the world. And of course, Humanitech, we are in the internal developer platform game. You can find lots of resources that we've put together on there. And as I mentioned before, that book, Team Topologies, by Manuel Peace and Matthew Skelton, is definitely worth a read. So that is the talk. Thank you very much.
Thank you so much, Chris. Thank you so much. If you're into it, whether you're watching the recorded version later, check out, or in a couple hours, we're going to have Manuel Pais, one of the authors of Team Topologies, is going to be one of the keynotes. So it should be good to not miss. I love this idea that while it may be a keyword, there's no such thing as a full stack developer. There can't be. Their heads would explode. as complex as the stack is, but there can be a full stack team, and we have to empower teams to get everything done and to be autonomous, not individuals, because frankly, it can be a bit scary, the idea of consequences. But as we abstract, even if it's internal, is there any risk of abstracting any of the important things like the things the devs need to know, whether it's security or ethics? Is there any risk of over abstracting so devs don't see what they need to see?
So I think there's always a risk of over abstracting, especially in the software industry. We're really good at building abstractions on abstractions. I think the key question here is that balance of this cognitive load. So how can you remove all of the decisions that really don't need to be made by a developer from their plate? So if they're designing their code, they should be worried about the security of their code. They shouldn't be worried about the security of the database or how the networking is set up that their code uses. There's usually someone who's much better at that and knows all of the ins and outs. Make sure that they're doing that. So rather than making too many abstractions, I think what it does is it allows people to focus on the problems that matter in their area of responsibility, which I think is the key driver for internal developer platforms.
Not expert in everything, domain expertise teams. Great.
Exactly.
Thank you so much, Chris. We are ready for a break. Don't forget to share what you're learning at hashtag WTF is cloud native. It's time for networking. If you don't have any meetings yet, you can go to the people tab and explore, or why not go click on the sponsors and talk to Becky, Peter, or Talbot at Instana and learn how to automate your observability and application monitoring. Or go have fun and at our lunch and draw, no matter what time of day it is and no matter what you're eating, in track 4. Thank you so much, and I'll catch you back in a bit.